Welcome to a bonus video on access control lists. Please do remember that the information herein is not something you are required to know. However, for those of you wanting to move a little bit beyond the standard 9-bit model of permissions, that would be what we talked about earlier, and it would look something like this. The 9-bit model, 1, 2, 3, 4, 5, 6, 7, 8, 9. The 9-bit model we discussed here, where the first 3 characters are for the user, the second 3 characters are for the group, and the final 3 characters are for all others. If you want to move beyond that, you can do so with ACLs. ACL stands for Access Control Lists, and they are used in other operating systems. The 9-bit model is a Unix or a Linux kind of file permission set. And so access control lists are used by Windows, and they can also be used in Linux. What do? Access control lists allow you to specify further permissions for specific users or specific groups, which of course would then grant those permissions to all members of those groups. So I will be showing you the getfacl command, or as I'll call it from now on, getfacl. Funny sounding word, I know, but you get sick of saying getfacl, so getfacl. To actually view permissions, we're going to take a look here at the current access control list for the test36 file. And I'll also show you the setfacl command, or the setfacl command, along with a few options so that you can modify the access control list. But let's just go ahead and take a look here at the test36 file. You can see right above the command line here that the user : has read, write, and execute privileges. That is the user that owns the file. And it shows you who owns it. I own it. Cody owns it. Cody is allowed to read, write, and execute this file. Okay, the group owner, which is also Cody, is not allowed to read, write, or execute the file. And then you can see mask here. Mask is going to set the upper limit for the group which owns the file, for all named users, and for all named groups. Now, what I mean by that is that if we use setfacl and then M for modify, followed by group : and then read, write, and execute for test36. What I'm doing here is I'm giving the group which owns the file read, write, and execute privileges. You can see that I've done that here. But if I were to change the mask, and I can do that in the same manner, if I were to change the mask to restricting read, write, and execute privileges on this file, and we can see that here, then even though the group which owns the file is granted 7 permissions in binary, it's granted read, write, and execute privileges, the mask will make the effective privileges, which you can see off to the right, a 0. No read, no write, and no execute privileges. So let me say it again. The mask component of the access control list will set the upper boundary for the group which owns the file, all named users, and all named groups. So that if your mask is set, as mine is now, to 0, then it will not matter what group is set to, what the group owner attribute is set to, or if we set a user, which I'll show here. So setfacl and then the M option for modify, followed by user : and then the name of the user, in this case Liam, followed by another : followed by the privileges that I would like for that user to have, and of course the file that I want them to have those privileges on. We can then take a look here and see that the mask automatically updated itself. Okay, Now, why did the mask automatically update itself? Well, because if you're explicitly giving a user read, write, and execute privileges, the system is assuming that you want that user to be able to read, write, and execute this file. And if our mask were still set to 0, 0, 0, no, sorry, just 0, if it were set to no read, write, and execute privileges at all, so hyphen, 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 then that user would not be able to read, write, or execute the file. Let me go ahead and demonstrate this. Okay, this would be silly. What we're about to do really does not make good sense. But it's for showing you how the access control list, how mask in the access control list can affect a file. Now you'll see here that the user Liam has read, write, and execute privileges, but off to the right, what do you see? You see a little comment there. It says effective. Liam's effective privileges are 0. He cannot read, write, or execute the file. And if you really don't believe that that's the case, then we can assume the identity of Liam and we can check it out for ourselves. So if Liam goes to concatenate this file, he will get permission denied. Why? Because the mask is setting the upper limit. And in this case, it's saying nobody can read, nobody can write, nobody can execute. So let's just pop back here and get it to recalculate. What I'm going to do is set facle modify user, and I'm going to add Amy, who can read, write, and execute. The mask will be recalculated. So now the mask will be read, write, and execute, okay? And you don't have any of those comments about your effective permissions. Ubuntu Server 14 is really awesome for commenting the effective permissions like this, and past versions did it as well, but it just seems like Ubuntu 14 is very friendly to access control lists and using ACLs in general. In previous versions of Ubuntu, you had to install ACL, and you had to go to the file system table, and you had to specify ACL. Now, ACL in Ubuntu 14 is a part of the defaults. So by default, on your file systems, ACLs are going to be enabled, which is just nice. You know, little bit of convenience there. Okay, so I hope you're understanding how this works here. You are able to use an access control list to specify the permissions for a particular user. Let me go ahead and change Amy's permissions. So set FACL, modify user Amy. Let's say that I want Amy to be able to read the file, but not write or execute the file. This is the code right there. This is the command. Now you can see that the mask is read, write, and execute. What does that mean? It means the upper boundary is that people who have the read, write, and privileges can read, write, and execute. Read, write, and execute privileges. But for people who are restricted like Amy, the mask is only setting the upper boundary. So it's going to check the mask and say, hey, can I give anybody read privileges? Can I give anybody write privileges? Can I give anybody execute privileges? Then it's going to check with the user that you've specified here, in this case Amy, and say, okay, yes, I'm allowed to give read privileges, and Amy has read privileges. Then it says, okay, I'm allowed to give write privileges, but oh, Amy doesn't have write privileges. I'm allowed to give execute privileges to named users, named groups, and the group owner, but Amy doesn't have execute privileges. So we can see this as we assume the identity of Amy. We log into her user account here, and you can see that we can concatenate the file. And please note, we will be able to open the file in Nano. Okay. Amy was already here, according to that. Amy was here again, we'll say. Okay. And when I go to modify it, I will not be allowed. Permission denied. Okay. Because of those, because of the ACL there, the access control list. So this has been a very brief overview of access control lists. That's why it's a bonus video. But I want you to be aware of a few things before I end this video. Access control lists are very powerful, but they also complicate the permissions that are on your system. And things can get very messy with ACLs. I believe that the 9-bit permission scheme that we discussed previously, where you're specifying the user that owns the file has a certain permission set. The members of the group that owns the file have a certain permission set, and all others have a certain permission set. I believe that's very simple and a very elegant system. And you want your system to be as simple as it can be while still having the maximum power to get its job done, for the server to do what it's supposed to do, what it's designed to do. ACLs over time tend to clutter a system as users leave and accounts become inactive, and then you have all of these different permissions that are specified on files. It tends to get very, very messy. It's harder to maintain. I'm not telling you it can't be maintained. I'm just telling you that in a real world environment, ACLs get very cluttered. Therefore, unless you need to use an access control list, don't. If you don't need to use ACLs, I recommend that you do not. However, there's a lot of power to using ACLs, in particular when you're using a file server with Samba. Samba is going to do a very good job of trying to reconcile the access control list on the server with the access control list specified in Windows and with that user, okay? So ACLs are very powerful, but they complicate a system, and therefore system administrators should just be aware of what they're getting into utilizing access control lists. Okay, so get FACL or get FACL is how we can actually view the current access control list. Set FACL or set FACL with the modify option is going to allow us to change things for users. We'll go ahead and just take his away. Sorry, Liam, you're not allowed to mess around with test 36. Okay, we can see that change reflected there. If we want to remove Liam altogether, you can do that with the X option, just like this. You don't specify any permissions. You're just saying that you're removing him from the list. You can see now Liam is gone. Or just to show you again, we can remove Amy from the access control list like so. Using that X option there. And of course, for more information about these commands, you can always open up their manual and take a closer look. This has been a brief overview of access control lists. I hope that you found it informative. I also hope you understand this is not the end-all, be-all of instruction on access control lists. Since this is a beginner course, you will mostly be using chmod to change permissions, chown to change the owner of a file, and chgroup to change the group owner of a file. But know that ACLs exist. They're very powerful, but they do complicate the system, and they do add a certain level of complexity that makes it best that if they are not needed, they simply be avoided.